short video about the Earthship WOM here. You see that I did it a little different, and the reason I'm doing it a little different from Earthship, who only use these small filters that you can clean, is that I have used small filters and I've discovered that I really hate cleaning filters. That's one reason. And another is rain these days have a chemical in them called PFAS. It's actually like an acronym for many chemicals, and the only thing that can filter that stuff out is the activated carbon or RO filters. And so I wanted an activated carbon filter to filter out the PFAS chemicals, because the ceramic filters won't filter that out either. And so we have PFAS in the rain these days, and it might not be much. It might be like 1 in a trillion particles, but you don't need a whole lot of it for it to become dangerous, as perhaps many of you have seen in the news. So the difference between a standard Earthship WOM and the one I have is I use these big blue filters. You don't have to change these every month or every 3 months. I think once every 1 or 2 years should be enough. And I think because we reuse water here, they should be in for 2 years, and it just saves you a lot of work. And they're not that much more expensive. Maybe $30 more compared to these things. Another rule for filters is that the bigger you make them, the finer you can filter. So I made use of the opportunity to use filters that are 3 times finer than an Earthship, and that will keep the ceramic filter, which is the most expensive one, cleaner for longer. So here I have just a particle filter, 10 micron, and this is an activated carbon filter, 5 micron. And this supplies the whole house, and then I have the standard Earthship ceramic filters that you also find in the Berkey filters. Another thing that I added is these manifolds. So you get a 3/4 PEX coming in that goes out to 4, depending on how many you want, different half-inch ones that goes to the washing machine, to the kitchen, to the eastern bathroom, and to the western bathroom. And the same is done for the drinking water, except I don't supply the washing machine with that, so there's only 3. And the same is also done with the hot water, which you don't see in this shot here. Now for the rest, it's pretty much a standard Earthship WOM. The water comes in, this is a pre-filter, filters out the big stuff so you don't kill the pump. It goes here, through the pump, and then out here to the filters. And you see there's valves here, and there's also a bypass valve, which is used if you want to prime the pump using the pressure of the system instead of the smaller pressure in the cisterns. And I put valves everywhere. There's a valve here, there's valves here. I can basically shut off everything individually to clean filters. And the nice thing about these manifolds is that if I have a leak somewhere, for example, I have a leak in the eastern bathroom, I shut that thing off and I have water everywhere else in the home. Another advantage is you can find leaks more easier. If I have a leak and don't know where it is, I can shut off these valves one by one and see if my pressure drops. And you can locate leaks that way. Plumbers would like to do this, they just don't have the budget in new construction to do this, so you'll only find the whole home shut-off valve. So here it is again for you to look at. Just compared with a standard Earthship filter and with this one. You see this faucet there, that is just to release pressure, you know. You don't want to push these red buttons here. They're usually used to release pressure, but they become leaky over time, so I don't ever push them. I use that valve. Another reason you want a valve there is because the pressure tank is right there, and you want to be able to empty that. So I can connect a hose there and empty that into a graywater cell, for example. You also see I have 2 valves, 2 gauges, and these 2 gauges, one is just at the pump, and this one is after the filters. So you can see whether the filters, if the filters get blocked, the pressure here should be a good deal lower than there. That's That's it. It's also good to have some redundancy. Then here I go to the hot water, and right now that is shorted to the hot water manifold, which splits in 4 just like the other one. And later on I can cut this pipe and go to the hot water heater. That's high up because hot water heaters have the exit higher up, and I'm coming from below anyway. And I made the most of it. I used leftover plywood from the roofing construction, and it was ugly plywood. I had to sand it a little bit. I put shelves up to make the most of the vertical space. Also this thing, to have that high up, I'm making use of this almost 10 feet of space I have here. And then there's this little oddity here. That is just to see how much water I have in the cisterns. The cisterns are full right now, and I have a lot of leeway up there, because if the pump starts running, or if you get backflow from the pressure tank, that water will go up a lot temporarily, and so I don't want it to come out. I can also shut that thing off. You know, if you have to prime the pump with pressure from the pressure tank, you can shut that thing off and the water won't squirt out there. I hope this helps you guys. I would seriously consider these big blue filters. They're about $70–80. And then you have to buy the filters for them, which you have to change every 2 years maybe. The particle filters you can wash, just like the Earthship ones. The carbon filters you'll have to change every year or so, because it gets used by filtering out the chemicals. Now, another difference with Earthship standard WOMs is I'm using a 120 volt pump. The reason is that I'm not having a 12 volt circuit in the home. I think inverters are stable enough these days and cheap enough to buy a redundant inverter to use this. The cool thing about this, here's the 120 volt plug. If you have a generator or like an EcoFlow battery, you can just run this on that. It's like 100 watts or something. So that's how I pressurized the system to test it. I did the same for the graywater system. Here's the recirculation line, and this is the filter for the toilet. And I used a big one there too. It's a carbon filter, for the simple reason that you really don't want to change this filter often, because it's gunk coming in there. For the rest, this is also pretty standard. There's a control valve, and there is a gauge to check the pressure. And then there's just these 2 lines, the recirculation line and the toilet line that goes to the other side of the home, to where the bathroom is. For the rest, the plumbing's pretty standard. It's all below ground, because I want to separate wires, electrical, from water. It's all on the ground, and goes to the kitchen here, and here it goes through eastern bathroom, and to the washing machine here. Now the blue lines run really underground. I had to run the hot lines obviously along the wall, because like I said, the water heater outputs heat on the top. And then here's the main bathroom. This will be the area where the tub is, just a shower and the tub faucet. Here the line splits, so it can go to supply the water to the vanity and also the toilet. Now the toilet is supplied by 2 lines. You can choose. To be code compliant, you have the standard water line. This is just clean water going there, and the left line is the gray water that comes from the planter, which we'll use obviously. Now another thing that I use is these guides. These metal guides are there to bend the pegs, and so you don't need copper stub outs. And I like that, because then all connections are visible, pretty much. There's only a few hidden connections, like this T here, that you don't see. And so all the complexity is really at the filter, where it goes through the manifolds to the various locations in the house. There's no split offs, or almost none, except for, like I said, here.